Hi, my name is Fran. In today's video, we are going to see a buffer calculation where a weak acid is partially neutralized by a strong base. So you may want to pause the video and try the exam question that follows. If you got the right answer, brilliant, well done. And you will have a stretch and challenge question at the top corner. If you didn't get the right answer, not to worry, that's why we are here. So we are going to go through it together. We'll go through a method for this question, where you can apply this method. And then we'll see some questions for you to practice a bit more and get better at it. So, first thing, if they give you the volume and they give you the concentration, just calculate moles for any topic, energetics, titrations. There you go. This could be 2 marks easily, and it's not too difficult. And then because we are in chemistry, then we love the balanced equations, so we need to write one. If you don't write a balanced equation and you just do your calculations, then you might be missing the molar ratio, which is not what you want. So yeah, you write it here. The molar ratio is quite simple. It's 1 to 1 to 1 to 1, so that's okay. Then you have the moles from before. You can see that you have fewer moles from sodium hydroxide compared to ethanoic acid. That means that sodium hydroxide is going to react fully, all of it. It's going to be the limiting reagent. So then the change for sodium hydroxide is going to be all of it. And to work out the change of acid and the change of salt product, then you apply the molar ratio, which is a 1 to 1, so it's the same moles. To calculate the final moles of acid, you do the initial moles minus the change. There you go. And for the product, you do the initial moles plus the change. Good. Eventually, we have a solution with a weak acid and the salt of the weak acid. And what is that? You tell me? It's a buffer. That's a buffer. So yeah, now we calculate the volume of the buffer, which is this 20 centimeter cube plus this 25. You've got the moles from before, you've got the total volume. What comes next? Concentrations. There you go. And now when you have the concentrations in the buffer, that's when you can use the Ka, rearrange it. That gives you the concentration of protons. You've got the values for the Ka from before. The concentrations values are here. And then this is the easiest part of the question, minus log it. You've got the answer. Second part of the video, where can you apply this method? In any pH calculation where you have the reaction of an acid with a base. It could be a strong acid, it could be a weak acid. That's a practice question for you. That's the answer. If you don't get the answer, check this video. It will help. And that's the second question. If you don't get the answer, you feel free to ask in the comments and I will answer you. That's all. Any comments, feedback, they are very welcome. Very pleased to see them. That's all for today. I'll see you in the next video. Bye-bye.